Okay, cool. So I missed class on Monday. Do we want to meet again on Friday for any like end of semester kind of questions or follow-ups? It's up to you. Let me know as we're kind of working through today. And this week's meant for review or trying something new. So if you can either work on module 5, or we can go back and look at anything from modules 1 through 4, like anything that came up or like things that never really made sense, but maybe on second look kind of all comes together. So what's everyone working on? Sorry? Review, okay. Review or 5? All right, I'll check in, see where we're at, and then we'll go from there. Open. All right, great question came up about like, how do I just take everything I've done this semester and just download it, get it off of this server and have it myself? I was trying to find, I thought we could just check a box, like check all these boxes and say download, but it doesn't have that option. But if you pick like a single file, there's this option to download. So really want to take everything in here, turn it into one file, and then download it. So 2 steps. So we're gonna make a new terminal. If I say list, it'll list like everything in that folder. So this is everything that I've done this semester. So I just want to go up one folder. CD ... is just move one folder up. Then I think there's, yeah, zip, and I always forget how to use this one. Zip a folder, Linux. Zip folder name. All right, so it's the zip file name and then the folder name. Yeah, so it goes file name, then folder name. So zip So now there's like this folder, or sorry, this zip file that is my fall 2025. I can say download, and let's see. Oh, it's only a folder? That's annoying. Let's try again. So how do I zip the whole folder? Oh, zip a directory and subdirectories. So I need a -R. And again, I always forget how to use zip. I have to look it up every time. All right, that looks a little better because it's actually adding everything that I wanted. It's not just zipping the folder itself, which is not very helpful. So now when I come back here and I say, yeah, now it's 117 megabytes. I can download it. And it takes a couple seconds to download, but it'll get there. Instead of 160 bytes. That's pretty small for a whole semester worth of work. I guess it depends on what the class is. But then there's also the option of just like keeping everything updated on GitHub. Since this whole thing was built in a GitHub page, you can fork everything, kind of update there. All right, so now I have like everything in this zip folder. All my stuff in there. Yeah, if you're interested. Yeah, and that was the thing that I had to do. Just zip -R and tell it where to save it. Okay, yeah. And I'll let TAs know, like, go back and, like, especially this week, make sure that, like, resubmissions, they look like a big, always reach out, say, thanks for feedback. Yeah. Sorry, give me some context. What were you talking about? Okay. Yep. Okay. No, you can submit those. Yeah, yeah, that's fine. Yeah, especially if there's just like problems that you didn't get to, then it's worth going through those. Okay. So let's go. Learn email. So just like logistics of getting grades in, because there were just some questions about like grades, resubmissions, and this kind of thing. Anything turned in next week, like there's not going to be any time to resubmit it. I know, so it sounds like module 4, the homework and project, haven't been returned, so I'll check in with TAs, see what the timeline is for that. Send out an announcement. And then, yeah, same thing with like module 5. Like part of the reason it's bonus is that there's no chance to revise it and resubmit it. It's just kind of get it in, and then it's done. And then anything after this, like December 12th that gets turned in, I'll count it towards the grade. Like it won't just get thrown out or anything, but you won't be able to resubmit it, and probably not much feedback on it. It'll just be like, okay, here 85 or something, just a number to get some points into the system. And then it sounds like as great engineering students, you're kind of optimizing which assignments need to get turned in. Maybe there's even an Excel sheet, hopefully like a Python script to figure out like which assignments I need to turn in to get to this minimum level. Awesome. It's totally support it. Definitely optimize your time. But one of the things you can't do is also just like, if you got some if you go back to module 1 and you look at that feedback, it's going to be so much easier to do those problems than it was the first time you looked at it. You're a very different person now that we've gotten to this point in the semester. Like you have a lot more experience, things are a little easier, you know what tools to use, where to look for them, things just come easier. There's also stuff that we learned that would make a lot of the stuff we did in module 1 easier, like root finding methods and integration, all the like the solve IVP integration methods and stuff. So yeah, encourage you, even if it's just like you got a 90, like let's just bump it up to 100. You don't have to. Again, like your time is your time. You should be getting things done that you need to. So that's my unsolicited advice for that. Yeah, coming in here. I think these first couple of problems we didn't have too much problems with. But like this idea of, there we go. This idea of like truncation error, like we looked at error in different integration methods. So now this one, again, it's not like it's easy, like, now it's so easy, but we've dealt with computer error a lot more since we first looked at this. So it might be a lot easier to kind of come back, like, all right, what is the error here? Like, how do I define that? How do I plot it? Make some for loops, get some AI help, and like refactor my code. It's a don't like extra credit. But if there's problems that you didn't do, then just do those and just like submit it before, rather than waiting to get like a second meeting. So we'll do that. Okay. Also quick question. Yes. Yeah. Is there some specific associated with that? I don't know. Yeah. Did you get anything first presentation? Okay. I wasn't sure. Yeah, usually Professor Marino, Professor well, a whole bunch of stuff and figure out. Yeah, it wouldn't hurt if it's all extra. Yeah, like second and third. Yeah. Yeah, like you'll always have like a nano channel. So anytime you log that case, you can go. Even if you use their computer, that folder will be there until you're noted. But because it's not like it's not a Yukon. This one's good. So module 5 is kind of getting back to a lot of the module 3 work that we were doing. Like most of physics is all like differential equations. Like here, this force causes displacements, but it's not directly connected. It's like second derivative. So a lot of numerical, like scientific computing, is how do you solve differential equations? And in this case, like if you know the boundary values of like what happens at the beginning, what happens at the end. One thing we looked at was like the shooting method of like a guess and check. Keep guessing the initial conditions until you match beginning and end. But we can also do that with like derivatives in linear algebra. So like turn a infinite derivative into a discrete set of like linear algebra equations. And first step to that is just like, what is a derivative? So here, if I have like these red dots are defining a sine wave, I could look at the slope in between each of those dots and see how closely that matches the actual like orange line, the cosine of x. And this is kind of normal, is we always end up with like an off by 1, where either everything's kind of shifted over to the left by a little bit because I did a forward difference. If I do a backward difference, then it shifts it over to the right. And we saw this in module 1 with our trying to define that heat transfer coefficient. Like if we did a forward difference, it was whatever, 0.4. If we did backwards, it was 0.3. They were both wrong for different reasons. Central difference is a way of like splitting, like getting rid of a little bit of error on both sides and just kind of split the difference. They're both wrong. Central difference is less wrong because it's second, rather than first order convergence, it has second order. Usually if you're doing like linear algebra solutions, you use central difference because it's kind of like you get a free second order convergence just by kind of more carefully defining your derivative. All right, so here, these are kind of defined with like indexing. So I'm saying like let's just look at y. So I have these like 10 values of y. Is it 10? Maybe 11. 11, yep. And when I say start at 1 colon in this part, I'm saying start at that first value, so this 5.9, go to the end and subtract 0, but go to the second to last value. So I'm taking these two, so a 1 colon is everything except for that first value, and then that colon -1 is everything except for that last value. So I'm taking those two vectors, subtracting them, and now I have, it's the same, it would be the same thing as if I said np dot diff of y. It's just I'm writing out that value. But another way that I could do this is create a matrix. It's like, why are you bringing matrices into this? We just finished that, we're all done with it. But I could create a matrix that multiplies this vector by 1s and 0s. And p dot 1s call it like dx. So first I want to take, and really I want that one to be like a negative, right? I want to take all the values of y in the current, like in my current one, like y0, y1, y2, multiply that by -1, and then so I'm creating like a matrix that does that same indexing. And this is the main idea for like module 5. It's like kind of taking module 1, like the first reading, and like skipping ahead to like how do I define differential equation? So now if I say dx at y, I get these values that should be my derivatives. So let's try it. Oh, but I didn't divide by dx. So that would help. Everything looks, it's the exact same thing that I got before. Only difference is this extra dot at the last time step, because it doesn't really make sense to use that last one. Like, there was no, if I look at what dx was, it doesn't really make sense to say that the derivative is a negative, like, y value. So really it's like everything except for that last one. And yeah. So this one's kind of like a nonsense one, but the rest of them all kind of make sense that way. And we can do the same thing for like second derivatives, third, fourth. Usually fourth order is about as high as you get. I mean, control theory, you get higher order derivatives, but for like solid mechanics, usually stress is like fourth derivative of displacement kind of thing. So these are a good starting point if you can do 1 through 4 derivatives. And for the most part, we're looking at central. So if I wanted central derivative, I would say this would still be a -1, but that's -1, comma -1. Put the ones on the off diagonal. And now my central difference looks good, again, except for that first and last point, because it doesn't, oh, and I forgot to divide by dx again. There we go. It looks fine, except for that first and last point, where again, it doesn't really make sense to take a central derivative at the beginning and end where there's no like bordering stuff. But the matrix takes a derivative of that vector, and it would be the same matrix, like the bigger the vector, the longer those diagonal terms, but it doesn't really change like the values inside there. It just changes how big they are. Anyway, if you're looking at module 5 or kind of thinking about it, this is kind of the two-step process, is like, what is a derivative, and then how do I define that? How do I define it as a linear algebra kind of problem? but yeah, feedback needs has actionable insights. So like, you're thinking with, like, if you look at it as like a matrix, or the way that I did it, then it is kind of over. And -1 is now is that bottom, and then the ones are all on that. That would be like the matrix. Right? So if you're typing it out this way, forward and backward have everything. They're exactly the same. Forward or backwards. The only difference is like, are you defining the first at time 0 or delta or whatever that next 0 is that first delta x. So backward is the first delta x. Yeah, most of these 5
Here's my passport. Okay. Thank you. Yeah. Get to upload pictures of it.
Yeah.
So he compared it.
Yeah, so that one's
And it's just like
grabbing
segregated
data points from something. Like it is a continuous function. Yeah, we agree. Because at least whenever you take the derivative is like math thing. Take undoing all that. It's a delta y. Sorry, delta y is like the y one. Like that would tell you y2 minus y1 for slope. So at least in the second degree. Or sorry, y. Minus y1. And then the next one down is y4 minus y2. It's kind of easier to see like with just a first derivative. Yeah, and slope is 2 points. So it's taking a rise. Taking the difference of y and then dividing by that. Here, delta plus. For second order, like it's the same kind of format, but all the differences now, like like there's you have -2 along the back, and 1 is on the back. So it's like your first and second line, then second derivative, first one that you can calculate delta x is f of x 3 minus x 2.
Yeah.
And then plus
Yeah.
all divided by delta x. Yeah, to get that first. Yeah. It works really well. And at first it just seemed like, okay, it's kind of silly, why don't you just use whales derivative when you have continuous differential equations where you know differential equation, but you don't know any of the functions. Like I don't get what you're supposed to. It's really cool. That one is, so I put it in this is like there's other higher order terms. And all the higher order terms, the biggest ones are really that should be an approximation. Yeah, as long as delta x is small, but that h is delta x. As long as the step size is small, x squared is very small. Yeah, but let's say get bigger. Less than 1 minute. Usually it should be yeah, there's all sorts of weird edge cases where it's really big for every reason. For the most part, simple problems. The small agents make the distance. Let's say you're trying to do fluid dynamics maybe microsecond, right? Like it's really small. Meanwhile, fluids are cheaper. You might have something where delta T fluid is super small. Yeah, just like your chemical reactions. It would look huge. Yeah, those are all like really stiff. There's that are so different. Same thing happens with like let me look at vibrating all the atoms are like femtosecond vibration beams. Hertz. Yeah, so it's different. Issue. No, yeah, that is a definition of area. It'll like I'll use that.
Go to like the place where we really feel like things at.
Yeah.
And
If you have one, just list it down.
either shots
Same thing.
and like, you know, just concentrate.
Yeah.
So the whole nauseous. And I have to trade.
Right? A good one. Oh, and did anyone think of for Friday? Do we want to be here or as needed meet up? I'll be around Friday morning either way. You want to just meet in my office if you need to? Okay. All right. And good luck on finals.
Have a nice day.
You too.